Hello everyone, my name is Nikhil Raghav. Today I'll be delivering my first introductory video on this platform. It focuses basically on the class 11th. There's a notion of set theory there in the very first chapter, but I'm also taking an idea of classification of numbers. So our lecture 1 has a title given by classification of numbers, and this is our claim. At the end of the lecture, we'll try to achieve this expression, what basically it is. In order to achieve this, our claim, we need some prerequisites, that is some prior knowledge we require in advance. If we have some prior knowledge of first this Pythagoras theorem and second some basic notion of a set theory, then definitely with the help of these two informations we can easily achieve this one. And why I'll be requiring this, you will be going to know in short while. Let me move forward directly to the lecture. I hope you will enjoy. So as we can see in this expression, this bold capital N is a mathematical convention which is used for a collection of numbers starting from second, third or fourth even. This notation don't comes into play, but some numbers come into, which we often call counting numbers and are nothing but like this: 1, 2, 3 and so on. So these numbers are nothing but counting numbers which we have used. Why they are called counting? Because we have used these numbers in order to count certain objects. We have learned how to count certain objects. For example, if we recall, our teacher in our primary classes used to ask us how many students have come today in the class. So what he's trying to ask, basically the number of students enrolled as well as the number of students present today, how many are absent there. So what we are going to answer him at the end by counting the number of students present in the class, basically the strength which is the present, and certainly that number, that positive integer has to be a number in this list only, and there is no ambiguity in saying so. So this list, as you can see, has 3 dots, these 3 dots here, and these 3 dots are called in mathematics ellipses. And what does that word ellipses mean? That this list goes forever in a similar fashion as we have just written it over here. And if we go forward, we can recall that we have learned some basic binary operations which we can apply over this list of numbers. Binary means 2 and operation means the operations of addition, subtraction, multiplication, division. That's all for time being. So if I choose any 2 numbers from this list, then definitely I'll be able to apply the binary operation on those 2 numbers, and it's easy, we can easily verify that there is no confusion at all. So we can easily apply the binary operation on any 2 numbers given from this list. If for instance I take 2 numbers, say let's say any 2 numbers, for example we'll say 1 and 3. I have taken 2 numbers. If I apply the binary operation addition on them, then that's quite easy, and definitely we got a number which is, again this is 4 you cannot understand, but this is present in this list after 3. But if I change the binary operation from addition to subtraction, we find that the number comes out to be -2. And now there is a problem, because we encounter with a number which is not present in this list. So we can say that these numbers, basically these infinite many numbers, are not closed with respect to this binary operation. By close here mean basically the closure property. If you can recall it, closure property was that if we take any 2 numbers in any abstract manner, I am trying to say, suppose say A and B are 2 numbers, and you apply a star between them, where star is some binary operation, and in our case it can be plus, minus, multiplication and division. In our case, I am restricting this binary operation to to these four because our focus for today class is this classification of numbers. In addition, there are so many binary operations. If you go to some higher level of notion of mathematics, for example, say if you'll be going into learning, if in bachelor's, if you took bachelor's, if you do in honors in mathematics or simply mathematics, then there comes a course on group theory. So in that course, we find that there are so many number of binary operations which we apply over some set of given numbers which satisfy certain properties. So let's now come to our discussion. By closure, I mean that the resultant, suppose the answer is to be C, the answer comes out to be a number C, and that number again has to be from this list itself. But in our case, what happened, we observe that when the star was chosen to be minus and the A and B were chosen to be 1 and 3, the C came out to be -2, and which is not there in the list. You can easily see there is no problem in saying so. So where is the problem? Because the problem is now that we have just a notion of this list of numbers, this collection of numbers, and numbers are basically nothing but the member or element of this list. So we have to move from this notion to this notion now, and this is a standard convention used for the collection of integers. And now, as I have already said, integers. So we have to first extend our list because this is not sufficient with respect to the operation which we have just applied. So the list now we are bothered about is this 3 ellipses, -3, -2, -1, 0, 1, 2, 3, and so on. So this new list of numbers is nothing but the collection of integers. Every time I'm using the word collection, that's because I am using, it's a well defined. Collection means some, you know very well, I don't need to explain even. So this Z, German word, this, how this is provided, not Z, Z, you can cross check that. Then in the NCRTs we have, if you recall, Zehlen, there's a word for this notation. It is a standard, again, convention used to denote the list of, the collection of integers. Fine. And these are nothing but the members element of this list. And then -2 is now present over here. So definitely this list, you can verify again that same binary structure, that this is closed in terms of addition, subtraction, multiplication, indeed. But if I talk about the binary operation, division, then you can think whether it's closed or not. You can take some time and think, take any 2 arbitrary numbers and check whether the resultant is over this list or not. Yes. So you must observe that if we take 2 numbers, say for example -1 and 5, then this expression, when we have applied division over these two, is nothing but a fraction. We know from our clear knowledge, and indeed it has some decimal representation which is nothing but minus of 0.2. Now what is important here is not this representation, but indeed this expression is not here if I have applied the binary operation division. So I can say this list is indeed not closed with respect to the binary operation division. So again there is a problem. So again we have to expand our list in some sense, that there exists some more numbers which are not present here, of course, and they are there. Fine. So we have to move now to this place. I'll be discussing what this means actually, right now not. So we have now come across numbers of this form in general. If I can write numbers of the form, this Q can be expressed as a collection of numbers of the form A by B, where A comma B, now there comes this notation, I'll be explaining what it means. and provided B has to be non-zero. This symbol which we have already discussed, A and B, this notation means, this notation says belongs to, what it says, belongs to, or is an element of, or is a member of, and there are so many other synonyms which I will not be discussing. So, because we got the idea, what I want to say, that certainly A and B are coming from here. The choice of A and B has to be from this list itself. Provided this B has to be non-zero. Again, there is some reason behind that why B has to be non-zero. If you choose B to be 0, or indeed very close to, there's a problem. If you, for example, say this expression A by B, where B, I know I cannot take 0. If I take, what is the problem then? If you do the division, let's take an example. Suppose say A is 1000 and B is very close to this number. Indeed, B is not again in this list. Deliberately have taken to give you clarity why we cannot choose B to be 0. If you find the result, the number is so large, and if you expand this, go like increase these strings of zeros, you will find that the resultant comes out to be some tan raised to the power say m, where this m is again element of this capital N, means m has to be natural number, positive integer, tan raised to the power, and if this m is so big, then the number is, there's a term precisely called unbounded. So it's out of the context until and unless you choose it to be very close to 0. The resultant answer is always finite. But as soon as you took it to 0 itself, it stands towards infinity. So like it's not a real number indeed. I will not be using that term, that sentence, because I haven't defined, but it exactly the real numbers right now. So you get a clarity idea behind why this has to be non-zero. Fine. So our Q, the collection of rational numbers, and this set theoretic notation is nothing but a collection. Inside this there are so many numbers, and they are of this form which satisfy this property. And moreover, if I ask you the cardinality, think over this and do response next time. What will be the cardinality of this set? Cardinality means the number of elements or the number of members belonging to this set. Think over it. Do answer me in comments. Now this notation, what does mean basically in general? This A might, this is again an operation which we are applying on these two sets. Set is nothing but a well-defined collection of objects where each object is nothing but a member or an element of that set. Fine. For example, to understand it more clearly, if I say the collection of the alphabets in the English language, then this collection contains 26 members, and these members are nothing but a B, C, D till Z. Fine. Similarly for vowels, you can make a good collection of them. But keep in mind that collection has to be well defined. Now there comes a problem. If I ask you, suppose say list me your 10 best movies. If I ask you, then this collection may vary from person to person. For me, those 10 pictures which are my favorite may not be yours, and vice versa. So what's the problem then? The collection has to be well defined, basically. I'm not going in that much detail right now. So the set difference. This operation is nothing but the set difference. How this is defined? X minus, wait. This is set, let me write again precisely. Set difference, the binary operation, which this is this, which I am applying on this and this set, A and B are given two sets. Of course, I assume they has to be non-empty. Now, I feel I'm going more towards set theory. Non-empty means this capital A cannot be equal to this empty set. Similarly, capital B cannot be equal to this empty set. And this is nothing but a notation for void, null, and in the simplest sense, empty. Empty set. These are synonyms. And here empty means this set contains no element. So what I have assumed that these two A and B are non-empty. Basically this, they cannot be equal to this empty set. So certainly there are some elements in them. And this difference operation here, which I have applied. So the result is again a set and which contains some elements of this form X, where this X satisfies X is a member of A and X is not a member of B. There are different ways to represent this. I can write it like this: X is in A intersection B complement. Or moreover, through Venn diagrams you can understand it more easily. If this is your A, my apologize for the drawing, I'm not good that much on that. Then this part is A intersection B. This is B only. This part is A only. This whole is A. This whole is B. This is the intersection. And if I sketch it over all this, then this is their union. This is some universal set U. And by complement, I have used here the complement. The complement means, in general, if I find A complement is nothing but U set difference A, that is collection of those X for which X belongs to U and X doesn't belong to A. In general, basically, this is the complement of these whole set, the remaining unshaded part. I hope you'll understand it. Suppose if I have a right angle triangle, right angle over B, right angle over B, this is a right angle triangle. Then what the Pythagoras says, from our prior knowledge we know that it must satisfy this relation, where of course X and Y are nothing, X, Y and Z are nothing but the length of these three sides respectively, and these two angles has to, if I take the sum over there, then they have to be 180 degree, because all the three angles have to satisfy that angle sum property and so and so. Now I am free to choose X and Y because their length certainly they have to be positive indeed. If I choose X and Y to be suppose say 1 and 2, 1 square, 2 square, the resultant is 5. So now the problem is reduces to Z square equals to 5, or indeed Z square minus 5 equals 0, which is nothing but a quadratic equation in Z, and we know that a quadratic equation can have at most 2 real roots. I will not repeat because I haven't told what is real and not. So it can have at most 2 zeros. I can refine it like this. And that zeros are nothing but square root of 5 and minus square root of 5. If you solve it using the basics of identities, Z square minus square root of 5 square, we can write A square minus B square, A minus B, A plus B. Then this Z is nothing but plus square root 5 and minus square root 5. But in our context, this cannot hold, because why? Think over it now again. Because this Z is nothing but the length of the side of this triangle, hypotenuse in our case, and length cannot be negative. So simple. So Z has to be of course root 5. But now again there is a problem. Think, is this number square root of 5 belongs to any of the previous list we have discussed? Just make a cross check. Think over it. No. The answer is no, it doesn't. So what it means? Every time when we encountered with a problem, there was some another list of numbers present. In this case also, there are infinite number of numbers which are not present in any of the list which we have discussed. So what I can say, this square root of 5 indeed plus square root of 5 or square root of 5 belongs to this list, this difference. And what is it so? And in order to understand it, we should have an idea of this. So this bold capital R is nothing but the collection of real numbers. And what it comprises of? All those previous lists as well as these list of numbers, if you take them as a whole, then these are nothing but the real numbers, collection of real numbers. So it is nothing but R minus is nothing but, if we have understood properly what is R, then it's obviously clear using the previous definitions of set difference. Some text also use some different notations to represent these collection of numbers, and these are nothing but the collection of irrational numbers. Irrational numbers. So I can say it in a more redefined way also, or in a different way also, the same meaning. Irrational numbers are nothing but the numbers which are not rational, are irrational. Fine. And these have some form. These numbers have some form. Basically, the numbers which don't satisfy this property. What I mean by this, it's on the contradiction. Suppose that in our last problem, the z is came out to be square root of 5 is a rational number. Then if of course it has to be of this form where ultimately A and B again satisfy that property. B has to be non-zero. I'm not going to repeat it again. If it was a rational number, then definitely it has some this form for some A and B square. If I square now both the sides, squaring, don't write, don't skip it, squaring both sides, then this is nothing but 5 times A square upon B square, which we can rewrite like this. Now check your knowledge and think with this 5 is a prime or not. Of course, indeed it is. It is a prime number. I'm not going to explain now what is prime and what is composite. It's another problem for you. Find it today itself and drop an answer in the comment section. If you have some doubts, if not, then there is no need. So 5 is a prime number certainly. Now there is a property. If you recall again from your elementary classes, if P is a prime which divides A square, then P have to of course divide A. And if P divides A, then it means then A is nothing. By divides here I mean exactly division. Exact division, there should be no remainder. And if P divides A, then A has to be some multiple of 5. And that's obvious, otherwise it will not be able to. So in our case that A is nothing but B. No, wait. I have done some mistake over here. If you will be able to verify this, an expression like this, not that. So, sorry for this. So, from this property, 5 must divide A square, and again 5 should have to divide A, then A has to be some integer multiple of 5, and we have to choose a certain B in context to A. We satisfy these two property, and you will find that there is no B. From, of course, that list capital Z. So, definitely our assumption went wrong, and that there is a contradiction, that this cannot be a rational number, and definitely it is an irrational number and member of this list. So if now I take all of these collections, I move to this one which was our aim for the class today, and this is nothing but the collection of real numbers. This is the largest set. Indeed, there is one more when you will be learning. There is something called capital C, like this, and it is nothing but a collection of complex numbers. I'm not going to that much detail right now. So I hope we have achieved our claim, what we are supposed to. And one more point I'd like to clear. Why these follow relation, why this is like this, why these two are not related, which we have already answered, if you recall, that the numbers present in this list is not in this, but all the numbers which are present in these lists as well as these lists are there. So that's why they don't have any such relation in the form of subsets. So thank you so much. I hope you have liked this first video, introductory video, and please do drop comments, suggestions, and do like the channel and subscribe it if you find it worth. And please, thank you so much for your time. Thank you so much.